Hey everybody, welcome back to Workshop Quick Takes. Today we're looking at the XJ again. On a previous video I alluded to some of my wiring for the lights that I've put on the vehicle, and someone asked a question is like, hey, have you got anything posted about what you did there? Well, the answer was no. I didn't do step-by-step recording of everything that was involved with the wiring just because it takes so long, it's tedious, but let's review some of it, show some of the footage that was involved in putting it all together, and maybe that'll give you some ideas for what works on your vehicle. Okay, so this here is the 2000 Jeep Cherokee XJ. This here is the main fuse box, and this here is a fuse box that does not exist in nature. Normally, if you have this vehicle, then right here behind the battery, you have a giant actuator living for the cruise control, and then that goes up and then around over the engine to provide throttle control. Okay, so this here is pretty standard. This is your normal stock fuse box with all the parts and pieces that go in there, and there's a couple blanks, of course, because this was a Jeep Cherokee Sport model. It is missing some accessories. The modifications I made after changing out the battery terminals actually start right here. On older models of this vehicle, Chrysler used this box, and as far as I know, there was a mega fuse under here. But by the time they got to the later models, for sure the 2000-2001s, they had changed that to a fusible link. A fusible link is a wire that is designed to burn out and fail like a fuse, but it has a slightly different operating characteristic that can be desirable for certain kinds of high current loads. But even though they removed the mega fuse, they didn't remove the mega fuse holder. There's a couple things going on here. This lead here comes off the battery and immediately feeds power to this terminal here. The fusible link originally was just routed under this bracket for convenience and just came up under this cover and landed here. A little tricky to get this on camera, but I'll move it in a little closer so you can see it here. There's the fusible link. Here's where it splices into another wire. This wire is wrapped up to here, but if you pull the sleeve back, you should see it's black with a white stripe. And this wraps into this bigger loom here and goes down around to the alternator. So that's the alternator feed, and that is what the fusible link is protecting. And then second red wire off the battery goes down directly to the starter. This also attaches to a bus bar that feeds into the main fuse box here. And then from there, there's a wiring loom that goes in through the firewall over here, and a couple other places around the engine bay that takes off of these accessories as well. Okay, if you're having trouble following what we were doing under the hood, let's try it graphic art style. Facing the hood from the front of the vehicle as we were doing, this is the edge of the battery, and that had plus and negative terminal posts. Over here, somewhere in this area, is the chassis. Over here was the chassis ground. This is where it mounts roughly. There's a big ring terminal there if you've still got the OE cables in, and that's one of two negatives that come back to the battery post. There's a second negative going off over this way to block ground. This one is needed because the starter and the alternator are both mounted on the block, and the engine and transmission are on isolation mounts. And while you can probably find a metallic path back to ground, it's not going to do very well under high current return. And there even may be some sensors up on the engine that use a ground return path, although I think most normally ground through the harness, but it's always possible. Anything else in the vehicle grounds through the chassis, so you need this one securely attached also, and it needs to be bolted in with a reasonably clean connection over here. So if you're having trouble with any of your electrical accessories, these would be the first two things to look for, because if you've got a bad ground, you'll have all kinds of wonky behavior. The only other thing that can create similarly confusing behavior is a bad alternator in my experience. We then also have a terminal post over on the positive, and this one has two red wires coming off of it. The first of these are going like this, and this one is to starter. Now, in case you aren't appreciating the gravity of this, there is a direct connection from the positive terminal of the battery, which is a high current source, to the starter. That may not be true for every vehicle you work on, but for a lot of older vehicles, including this 2000 Cherokee XJ, that's how it's set up. So you always want to make sure that this conductor is in good condition, doesn't have any cracks on the insulation. You want to make sure that whatever insulating sleeve it has over it is in really good shape, because this is one connection that is not fused in any possible way between a high current source and a big piece of machinery over here. Let's draw the end of our fuse box up here. This is the OE fuse box, and this is the end where the mega fuse would be. That has a terminal post right here and over here. Originally, when I first came to the vehicle, this was just blank. The second positive connection from the battery comes directly to right here. So this is normally covered up and fairly secure. However, from here to here, there's no fusing device either. So if you manage to create a short circuit on this post for some reason, you're going to have a bad day. Now this post in turn connects to a positive bus inside the electrical box over here. All of the vehicle's OE accessories, and let's draw these little fuse squiggles like this without going into all the relaying and everything, are in this box. except for anything that is located in the interior fuse panel inside the cabin. But major things like fuel pump relay, headlight relay, any of that kind of stuff is usually out here in the engine bay. And to the extent that it is controlled from inside the cabin, only the control power goes in the cabin. The main fuse and relay for the high current accessories are always out here. There's another fuse here, and that is the fusible link. It comes off there like a little hook. That's assuming your Cherokee like mine is new enough to have this and not the mega fuse. And then it's spliced. Now I'm going to go ahead and draw this as a red wire, but in my vehicle, once you actually, if you peel back the split loom tubing and look at it, it's actually black with a white stripe for whatever reason. And this to alternator. This is a link that's designed to fail. It is a wire, but it's designed to fail gracefully. It'll still make a lot of smoke and some nastiness, but something goes wrong over at the alternator, this disconnects it. Well, so what I went ahead and did is I went ahead and removed the fusible link from coming around this way and put it on the outside here, and by doing that, I was then able to snap a 100 amp mega fuse back in here. The 100 amp mega fuse then just has this fabricated post connector over here, and there are 3 wires taking off of that. One of these wires goes to here, one goes to here, and these are fuses for the rear power panel, which I've talked about in a previous video that you can also watch on this channel. Those run down, go underneath the door sills, and then end up in the back corner. The third one, however, this wire here, comes back around and feeds this little fuse box. Right now, this fuse box has a position for up to 6 relays. I'm currently using only 2, one for the rear lights, one for the front lights, and each of those also has a master fuse on top of it. Now, to do this fuse box, I ended up just creating a bus bar underneath that feeds the fuses, and then the fuses can feed the relays. But the way the relays are controlled is that inside the cab, I grab a fused ignition circuit, use it for switching, and bring it back to the relay. So the relays are switching power directly from these incoming fuses to the lights, but the control for these relays is off of fused ignition power. So that way my lights shut off when the ignition is shut off, just like they would with OE. Some people might want theirs to run all the time when they're switched on. That's fine if that's what you want to do. This is what I chose to do. But the other thing that then happened by putting this fuse box here is I blocked off the area where the hood prop comes down. So I went on eBay and just found this little nylon hood prop that I think was probably for a Nissan or something, but it happens to be the right diameter to catch the Jeep's hood prop, and so that solved that problem. Okay, this is the OE setup. What have we done with it? Well, first of all, we've added the 100 amp mega fuse here. From the mega fuse, there are 3 new wires tapping off. These 2 have inline blade fuses and go to the rear power panel. That was a little sloppy, but hopefully you can read that. One of these, if memory serves, is 50, and the other I think was 20, it might have been 30, but either way, this will illustrate nicely a little principle you need to think about when putting in new cascading fuse systems in your vehicle. In general, every fuse is only guaranteed to fail at twice its nominal current rating. You run it up to some lesser current rating, it may fail, it may not. It may actually get hot and kind of glow and limit the current, but it may not actually pop. So, you do want to specify fuses so that each one down the line is at most half of the one up line, because we don't want to be running more than 100 amps continuously through this fuse, or we will start to affect the link in there. But again, it may not fail reliably, but it may weaken it, and over time you could get nuisance failures. But if it's a 50 amp fuse, it's going to pretty reliably fail at 100 amps, which in turn keeps this fuse from nuisance failing later. But if I have something happen over here, this battery on a bad day should supply a few hundred amps, and will easily pop that at 200. The third one stays here under the hood to our new fuse and relay box. Connection number 3 from here goes into this guy and hits a positive bus I created in here. Each of the 6 fuse slots that was in here was just with terminals, so from the bottom you could terminate a discrete wire to each one. But on one side, I decided to go ahead and make it a bus using some copper wire that I pulled from an old home improvement project. It might have been this number 6 that I used to install a missing second ground to a water pipe in the house, or maybe something like this number 12. But in any case, I made copper bus across one side, and so then there are currently 2 fuses installed in there, and there are 2 relays. Now I'm just going to give a typical illustration here. This is not necessarily the way the terminals are connected on the relays themselves, but let's just say it's in that corner. That's where the power goes into the contact of the relay, and then the output contact goes to the rear lights, to the front lights. Coming out of the fuse box down here, you can see there's a wire. and it goes down to a blue Delphi connector. That's this right here. That Delphi connector is then providing power to a simple front harness that goes to the front lights. Now we're about to change these out for a slightly different pair, but they'll connect at the same positions. So one there and one there are the floodlights shining out the front. I went ahead and kept them under the front bumper. I know some people like to do this for upper light bars. Coming around to the back side, we have these two here that are on the bumper. And again, those are wired with another harness that I routed through the back of the bumper. And then that comes back up inside behind the tail light here and connects through around where the power panel is and follows its wiring, also follows that harness up under the sills, back through the firewall and over here. Up there's the underhood light I'm not using at the moment. One thing you can't see to a great extent is where all the wiring is going, and that's because as much as possible I wrapped it into the existing loom and then rewrapped it. On a 20-year-old vehicle like this, you're probably going to want to do a lot of loom rewrapping if you care about it, because to show you some of what's going on, you get some of this old plastic tape breaking up here, but then you also have a lot of this old cloth tape. And you know how much oil gets under these engine bays when they're 20 years old or more. So you take tape like that that's soaked in oil and then turns into pieces and flakes off because it's old. What happens when it goes and hits something hot? Probably nothing good. I don't want to find out. So I haven't redone all the loom, but I've redone a lot of it for that reason, because it was breaking up. You can kind of see down there that there's some additional split loom tubing coming out of there, and then it comes over here and collects, but a lot of it then gathers together into this, and a couple other bits that you can't see actually go into the main loom. Now the main loom has an OE takeoff right here that goes through the firewall. There's a grommet right back there for that. But what you don't have on a stock Jeep that I added is I went ahead and drilled another hole right up next to the loom after making sure that it was clear back there, and added a second grommet to pass through. It's using something I got at the auto parts store, I think. And so that wiring ends up coming down next to the air box right by the main fuse power panel inside the vehicle. Now the main fuse power panel for inside the vehicle is right here. That's the usual place you go. If you've got a bad fuse, you start checking the block, it's back in there. But if you remove this trim piece by taking out the bolt that's down back under here, actually it's this one right here. If you remove that bolt and you remove some of the trim over by the door, you can remove this whole piece, and then you have access to the wiring loom that are behind there. So if you need to tap into an existing circuit or repair something that's gotten damaged, that's how you get to it. And that's also how I was able to come down and find the wiring that comes down back behind the air box from my new grommet. Likewise, if you look up here, you can see some of my new loom work going over to where the power switch is. It just goes under there and follows some of the existing loom, and then ends up back underneath the dash where it comes up by the steering wheel for my switches. Right up here then, in this blank space, is where I added two switches that provide the light controls. That there with the red indicator, that operates the front lights. That there with the blue indicator higher up operates the rear lights. I chose blue and more visibility for this one because I don't want to be driving around with those on unless it's very much on purpose. So if I see a bright blue light shining at me when I'm driving, I know I got an issue if I didn't intend for it. And of course, they both can be turned on at the same time. But again, fused ignition circuit, they will kill if I turn off the key. So those are the main changes under the hood, but now what operates these relays? Well, these need 12-volt power from somewhere. So there's two more terminals on here for the coils. Now what I did is, inside the cabin where the in-cabin fuse panel is, I went looking through the electrical diagrams, found a harness in there that has fused ignition power on it. Fused ignition power comes on with the key and off when you switch it off again. It might also be called accessory power. A few different places you can get that, pick one that works, but splice into it carefully, because obviously if you mess up that splice connection, then you're gonna have a whole bunch of other accessories that are on that circuit potentially fail also. But you get the fused ignition power, and then bring that to whatever switches in the cabin you want to control, and bring the output to the coil to relay. And then the output from the two coils can just go to ground. And so I've actually got, from this same panel, an additional lead over to the chassis ground here. So that's the negative return from the coils. Each of these, again, is not controlling the lights directly. It could because they're LED and the current draw is not that high. But to do it right, there's another Delphi connector back here that these connect through and then follows underneath like we were just talking and goes back around to those relay boxes. So the fused ignition circuit is taken out of the fuse panel over there from an available harness that it's spliced into. That provides the power to control these switches. These switches then go back to those relays and switch the relay coils. The relays then switch power directly from the fuse circuit that's under the hood and sends it to the lights. Okay, just a quick sketch of what's going on inside the cabin. Those rocker switches actually have a little LED in them. And the way that actually works is there's 3 pins on them. So if you assume that this is the switch here, and so it can, close, open, like that. So the blue one's on top, we'll just put BU here. So there's a blue LED on that one, there's an RD red LED on this one. Incoming wiring to each of these is positive to here. And coming out of there, these also need a ground because that LED has to have a path of somewhere to go. But then out of these, and I'll just draw it as a black dash wire, there's also a signal wire. This is the control wire. Now what I did down here inside the dash is I happen to have a 6-pin Delphi connector. I went ahead and wired all 6 of these out. And then if I ever need to change how this is configured somehow, I can buy another one of those 6-pin Delphi connectors and just replace the bottom half with whatever the new wiring configuration is. Once you get to the other side of the Delphi connector here, both of these grounds tie together and both of these positives tie together because they're getting the power from the same fused ignition source. So this is going to the cabin fuse box for fused ignition power plus 12 volts, and then this one's going to ground, and then finally these two switch with the red light, relay number 1 coil, front lights control, switch with the blue light, relay number 2 coil, rear lights control. There's 2 more incoming leads that I won't sketch on here because it's getting kind of crazy, that are from those switches in the cabin to turn on the lights. Now, I'm just using a couple of LED floods front and rear. I don't have like a gigantic light bar. I'm not using halogens, but nonetheless, they are primary lighting circuits. They're normally considered high current circuits. Control power in the cabin comes out to here, switches a relay. The actual high current circuit is entirely under the hood. From the battery to the fuse, here to these 2 fuses, to the relay contacts, to the lights, and back to the chassis. And that gets the job done. So just to get an idea what that is, let's take a look under the hood again, play with a couple of these buttons, and watch what happens. So first of all, rear lights, same thing. On, off. So that's not necessarily how everyone does it, but that's one way you can do it. On the 2000 and 2001 for sure, I think the 97 and ups all have pretty much the same electrical hardware under the engine bay. I don't know for certain on that. But again, where I put that fuse box is where the cruise control module otherwise would be. So you might have to look for a different place along the firewall or somewhere else under the hood if you want to do it differently. Of course, another option people sometimes do is they do an air filter relocate and then put a spare battery over here. There'd be room for a spare box over here next to that if you want to try that. There's options. The main thing is, with wiring, anything that can move will, especially in a vehicle that's on the trail. So if it's not secured down, it's going to flop around, it's going to break. If it's secured down, but it can chafe against something or has a little bit of play, it's going to vibrate. It'll chafe through and then short. So with wiring, the biggest thing is not to be afraid of it, but be afraid of not securing it. Be afraid of not wrapping it. So wrapping in tape, putting split loom over it, wrapping again, that's usually the starting point for making sure that you've got good protection on your wires, especially when they're traveling through tight spaces in the chassis. Hey everybody, thanks for joining us again today. Hope you found that helpful. That was part 1 in what will be a 2-part series on Jeep wirings and methods, focusing on, of course, my Cherokee XJ and auxiliary lighting systems. What we're showing you today, I've only used to put a pair of trail lights in the front and then another smaller pair of lights in the rear for accessing a trailer at night or something like that. But the principle is almost unlimited. You have your control voltage in the cabin, you have your high current circuits under the hood controlled by relays, and everybody goes home happy. And of course, make sure your wiring is neat. As you may have encountered on other YouTube channels, it's a common expression that the best wiring you can't see. And unfortunately, that's the case. You put in all that work and then nobody knows you did it, but it works and it doesn't catch fire. So those are the good things that you want in your vehicle, hopefully. In any case, next time on part 2, we'll try and take a look at what it takes to actually put all this together and use like Deutsch connectors, Delphi connectors, things like that, proper wiring methods and such. And the reason for that is, if you plan everything out in terms of where does it need to disconnect in the system, you can do things like remove your front clip, remove your rear bumper, remove a trim piece in the dash where you installed switches without having to tear wires apart or work awkwardly around things that are dangling. You can simply unplug them at logical places and it'll be exactly like it was all put there by the OEM. Same principles. So stick around for part 2. We'll be looking forward to seeing you there next time, whenever that is. Has anyone seen my phone?